Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Lakam Zainal. My matrix number is 200941. I'm from Dr. Azim Group. So today I will present about individual assignment Engineering Mathematics 2 ECC3012 on title Application of Heat Equation in Problem in Solving Thermal Conductivity Engineering Problem. So next we will go to overview of the overview of this equation of this presentation. So firstly, this presentation will be divided into 4 parts. Firstly is introduction, second engineering problem, third engineering method, and lastly will be the conclusion. So let's move on to the introduction. So for the introduction, partial differential equation require more than one independent variable. As we have learned before, we have seen so many partial differential that contain more than one independent variable. The wave equation, heat equation, and Laplace equation are known in engineering mathematics. So these three equations is the common equation that which can be seen in engineering mathematics and also always being applied in solving engineering problems. So heat equation is a parabolic equation. So since this engineering problem related to insulated wire, so insulated wire is a cable consists of non-conductive material. That means the heat from the wire can't easily move up. So next, we will go to engineering problem. So this is the equation giving wire of length insulted wire of length 1 and the end of the wire embedded with ice temperature 0 degree, and given the K is 0.003 and the initial heat distribution is given UXO equal to 50x 1 minus x. So this function is given. So the question asks us to find the temperature function UXT and the maximum temperature wire drop 1/2 of the initial maximum. Next, we will go to engineering solution. Okay. So the graph is given and we can see this is the common heat equation and the initial boundary and initial condition and boundary condition. So first step, we need to transfer the equation given to sign series based related to this equation. So we got this equation. After that, figure 2 show the plotted of temperature of the wire at position x and t. So the solution of U equal xt plotted in figure 2 between x equal to 0 and 1. So the given series is this function. Next. Okay, so we can see that from figure 2, the maximum temperature will be at x equal to 0.5. So we plug in x equal to 0.5 in the function given. So we will get the function of u 0.5t equivalent to 400 pi cube e negative pi square over 0.003 t. Next. Okay, so this function is temperature at midpoint of fire, approximation of this temperature using first term of series. Next. So yeah, so since this equation asks a half drop of 1/2, so 12.5 we divided by 2, then we substitute this value in the equation. So we will get the answer that maximum temperature will drop to half at T equal to 24.5. So now let's go to the conclusion. Lastly, for the conclusion, partial differential equation can be applied in a way to solve an engineering problem. So as I have explained before, this engineering problem can be solved using partial differential equation. So differential equation play major roles in application of science and engineering. So not only in engineering fields, science fields such as physics and many more can apply the differential equation. So the thermal conductivity, if this situation occur, we can apply the equation to solving the problem. So I think that's all from me. Muhammad Zakam Zainal. Thank you.